Here's a type of quadratic word problem. When we get it all set up and start to solve, you'll end up with some kind of a square term that we're going to have to use quadratic techniques to solve. So here we have a truck is going to travel two different types of highway. The first part of the trip is on a very flat road where the truck can go 20 miles per hour faster than it can on the second part of the trip, which is up in the mountains. So basically, flat road goes faster, mountains slower. For the very flat part of the trip, it's going to take 605 miles. The mountain part is going to be 280 miles. And the whole trip is going to take 19 hours to finish. So what we're asking for here is how fast was the truck going on both parts of the trip. So the best thing to do is to separate this into two parts of the trip. So you're going to have the flat part and you're going to have the mountain part. And usually with a word problem, I like going for the unknown first. So what we don't know is how fast the truck is moving on either of these. But we know something about one of the rates. It's 20 miles per hour faster in the flat. So we know more about the flat rate than we do know about the mountain rate. So we're going to call x the mountain rate, how fast he's going in the mountains, miles per hour. And if he's doing 20 miles per hour faster up here, then over here, the flat rate would be x plus 20 miles per hour. Okay, so that kind of gives the problem separated into two things, and you can worry about them individually for a little while. The flat, we know something else about it. It's 605 miles. And the mountain trip is 280 miles. Now there's one last thing that we know. We know that the whole trip took the driver 19 hours to complete. So this kind of gives us two variables that we have to work with. One of them is going to be considered a dummy variable, and we'll see what happens. So I'll just write that off to the side. The time it takes to complete this is going to be 19 hours. So this one's going to complete it in t1 time. This one's going to complete it in t2 time. Therefore, with this equation, we know that t1 plus t2 must equal 19. So if we can force this into our word problem, this would be the equation we have to solve. Find their times. Even though it's not really solving for x directly, if we can set this up, then we start going in the right direction. So I gave a little hint here. Time is equal to distance over rate. It comes from the d equals rt formula, and you just solve for t by dividing both sides by r. So if I set the first one up as d over r, d is 605, and r, of course, is the rate, which is x plus 20 miles per hour. And the other one, d over r, would be 280 miles over just x. Now both of these represent the time it takes to traverse the 605 and the 280 miles, which is t1 and t2. But over here I said that the sum of them had to be 19, so that's where our nice equation is going to come from. So the sum of the times has to be 19 hours. And we have our equation to solve. Now we have an equation with fractions, so the first thing I'm going to do is multiply both sides by the common denominator. And in this case, the common denominator is going to be x and x plus 20. So x times x plus 20. And we'll distribute it on the left and just multiply it on the right. Not much we can do over there. Okay, so when it hits the first term, the x plus 20s are going to cancel, and you get 605 times x. When it distributes to the second piece, the x's are going to cancel, and you're going to be left with the factor of 280 and x plus 20. And on the other side, again, it's just going to be, well, a mess. So it's going to be 19 times x plus 20. Alright, and then just get rid of parentheses, combine like terms, and try to get it into a nice quadratic form. So this will be 605x plus 280x plus 20 times 280, which is 5,600, is equal to 19x squared plus 380x. I'm going to double check my calculations just to make sure my brain's in the right place. 280 times 20, 5,600, 19 times 20, 3,800, 380. All right, and then combine like terms. Those would be those two, so that'd be 885 plus the 5,600 is equal to 19x squared plus 380x. And since the square term is involved and it's not going to go anywhere, this is definitely a quadratic, so I want to get it equal to 0. So let me bring my work up here. So I'm going to move these two pieces to the other side, so they'll both become negative. And on the left-hand side, we're going to get a big fat 0 is equal to 19x squared, and then 380x minus 885. So 380 minus 885 is negative 505. So we'll get a negative 505x. And then we'll have that negative 5,600. Now it would be really nice if you could factor this, but it doesn't look like it's going to be a nice factoring. You'd have to multiply 19 times 5,600, come up with factors of that actually subtract up to 505. Not going to try. So the next best thing, quadratic formula. So let's see here, negative b plus or minus the square root of, this is going to be quite long, b squared minus 4 times a times c. Let's see if I can squeeze it in there. All divided by 2a. Alright, so we're going to get x is equal to, oh, might as well plug it in up above and see what happens. So let's see here, this is b, so this is negative 505, so that'll become positive. This is also negative 505, but because it's being squared, the negative is irrelevant. A is 19, C is negative 5,600, which is good because this negative and this negative will be positive, and this will be the square root of a positive number. And then down here is A is 19. So let's figure this out. So 505 plus the square root of, well, let me do the inside first. 505 squared plus 4 times 19 times 5,600, changing the negative negative into a positive. So this becomes 505 plus or minus the square root of 680,625. Sounds like a nice number. All over 38. All right, let's see if I can square root that ugly number. Oh, comes out as 825. So this becomes x equals 505 plus or minus 825 divided by 38. Now, remember, this is a physical problem. Things aren't going to be negative. So more than likely, 505 minus 825 is not going to be part of my answer. So I'm only going to do the positive part and then divide that by 38. And we get x is equal to 35. Now this is nice when you come back up here and say, what does x represent? Well, x is miles per hour for, well, the mountain. So this is 35 miles per hour mountain path is how fast the truck is going. Therefore, come over here, it's x plus 20. So the other one will be 55 miles per hour. Oops. On the flat terrain. And there we go.